Today we will do number series questions in marathon style. We'll cover a lot of questions today, mm, uh, 20 to 25 questions. It is going to be a long video, but in this long video covering all these questions, I will cover a lot of logics that I have encountered in number series questions. And if you note down the logics in your own copy, uh, and keep revising those logics and keep those logics at the top of your head, just like you remember tables or squares or cubes or prime numbers, uh, mm, like them, just like them, you memorize those things. Similarly, if you memorize this 20 to 25 logics and revise it on regular basis and keep this logics at the top of your head handy in the questions, as soon as you see the question you will be able to figure out the logic. Keeping that in mind, let's start the question. Let's see the first question. uh, this is the series of numbers that is given to us. We have to find the wrong number between the feel free to pause here and try yourself. Okay, so the first thing that we do in number series question, um, if the numbers are looking odd to me and nothing is coming at the top of my head what to do, the first thing that we do is calculate consecutive difference. If nothing comes to my mind, the first thing that we do blindly is calculate consecutive difference, right? So for difference between 40 and 53 is 13, 53 and 75 is 22, 75 and 108 is 33, 108 and 150 is 42, 150 and 203 is 53, 203 and 263 is 60, and 263 and 338. Sorry about the technical glitch. Let's continue. Yeah, and 338 minus 263 is 75. So looking at the difference, can we mm, see anything? One thing that I'm noticing is that if I'm not able to understand, figure out anything from the difference, I will take the difference of difference. So these are the series of difference, so we'll take their differences now. 22 minus 13 is 9. uh, 33 minus 22 is 11. 33 minus 42, sorry, 42 minus 33 is again 9. Okay, so I can see a pattern over here. Okay, 53 and 42 is again 11. Okay, so now by taking the difference of difference, I see that the difference of difference is going alternately with 9 and 11. So this difference must be 9 and this difference must be 11. So if this difference is 9, that means 53 plus 9, it should be 62. It should be 62, and if this is 62, this should be 73, right? If this is 62, then this number is my wrong number. This should be 265. And if this is 265 and adding 73, this is my correct number, 338. So here the logic was difference of difference goes alternately. Goes alternately between 9 and 11. That is my logic. Okay, let's see the next question. I have to find the missing term. Take my pause here and see if you could solve this question on your own. Okay, so the first thing that we do is take difference. 78 minus 62 is 6. Difference is 6. Or I should say 172 minus 178 is minus 6. Because I'm seeing this is a reducing series, decreasing series. So as you subtract the bigger number from the smaller number as we go on, we'll get the difference in negative. So 172 minus 178 is minus 6. 147 minus 172 is minus 25. Okay, whenever I get a 25, I get happy because it's a square of 5. So we can start thinking in the similar terms. 83 minus 147 is minus 64. Okay, 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 again 64. I'm happy about it because it comes in the power of 2, and 2 minus 83 is again minus 81. Great, again it is a perfect square. It is a perfect 64 is a perfect square, 81 is a perfect square, 21 is a perfect, 25 is a perfect square. Great. But what about 6? Hmm. So this is my 8 square, this is my 9 square, this is my 5 squares. 5, 8, 9, 6. Okay. Can we write 6 as 6 to the power 1, 5 to the power 2? Yes, we can write, and we can write 8 square as I can write 8 square as 4 into 2 square that is 4 square into 2 square, that is 4 square into 2 square is also 4, so we can write 8 square as 4 cube and 9 square as 9 as 3 square to the power square, so we can write as 3 to the power 4. So what we are seeing that it's going like 6 to the power 1, 5 to the power 2, 4 to the power 3, 3 to the power 4. So hmm, base is reducing, or my base is reducing, mm, and exponents are increasing. Exponents are increasing simultaneously. So here my logic is base increasing and exponent decreasing. That is my logic over here. If that is my logic, then what should be the missing term? What should be the missing term? Missing term so should be uh, base, sorry, I made a mistake. Base is reducing from 6543, base is reducing and exponent is increasing. This is one logic. So the next term would be base is reducing after 3, 6, 5, 4, 3. My next would be 2, 2, and exponent is increasing 1, 2, 3, 4, 2 to the power 5. That will be 4, 8, 16, 32. So 32, and so all these were negative, so this will be minus 32. So if this is my x, x minus 2 should be minus 32, which implies x is equal to minus 30. That is my answer, minus 30. So see, if this is my logic for this question, need not to say that the alternate of this logic can also come in the exam, where base increases and exponent decreases. Here base kept decreasing with step of 1, 6, 5, 4, 3, 2, 1. It could have gone like 6, 4, 2, or any integer form, and the power has increased with 1 at every step. So 1, 2, 3, 4, 5, 6. Instead of 1, 2, 3, 4, 5, 6, it could have gone at an increment of 2, 1, 3, 1, 3, 5, 7, like that, or increment of 3, or any integer number. You understand what I'm saying, right? So these are the logics. Okay, let's see the next question now. Pause and see if you could solve the next question. Okay, so one thing to note is that whenever your series is taking a huge jump, so it is starting from a very small number 4, and by the end it has reached to a big number as compared to 4, 5, 12. So it has not increased much in this region, in the first region, in the first region, but after that first region it has taken a huge leap forward. Then that the number by the end has become very large. Whenever you encounter this scenario, know that there is some multiplication involved. So the logic is huge um, leap in numbers means multiplication is involved. It can be multiplication, not only multiplication, it can be multiplication or cubes or squares are involved in the pattern of the series that you need to identify. So start thinking in terms of multiplication, cubes and squares. Not mm, here in this case taking difference doesn't help. In this case taking difference may not help. Not This is not an hard and fast rule that difference may not help. This is not an hard and fast rule. It may or may be involved uh, where we have to take the difference and the difference will follow some multiplication or cubes or squares patterns. Uh, but this is for sure that whenever there is a huge leap in number, either multiplication or cubes or squares, one of the three is in there in the logic. Let's find out the logic. Here I can see that we can express 5 as 4 into 1 plus 1, right? So 4 is my previous number and next number can be previous number into 1 plus 1, and 12 can be 5 into 2, 10 plus 2. Do I see a pattern over here? Yes, I see. So my next number is getting multiplied by an integer 1 2 as which keeps increasing with that integer multiplies with the previous number, and uh, the same integer gets added. Let's see if my logic holds for 40. So 40 should be 12 into 3 plus 3. 12 into 3 is 30. No. So as I was saying that this number is of the same integer that is multiplying the previous number, apparently not. So 40 will come as 12 into 3 plus 4 will give me a 14, not 3. Okay, if this is the case, that means these numbers are increasing at an increment of 1, and this number 1 can be written as 2 to the power 0, 2 can be written as 2 to the power 1, and 4 can be written as 2 to the power 2. So this is increasing in the powers of 2, right? Let's see if our hypothesis holds or not. So the missing number would be hmm, missing number would be 40 into 4 plus 2 to the power 3. Let's see, 40 into 4 is 160 plus 8 is 168. If this is my if missing number is my 168, then can I reach 856 with the same logic? So 856 should be 168 into 5 plus 2 to the power 4. Is it coming? 868 into 5 is 840 plus 2 to the 4 is 16. Yes, it is indeed coming 256. So our logic is correct. So here our logic is to get the next number, previous number is getting multiplied with an integer which keeps increasing and gets added with the power of 2. I hope that is clear. Let's see the next question. I have to find the missing term. Okay. If I'm not able to understand anything, first what I'll do, I'll take difference, consecutive difference of consecutive numbers. So 310 minus 78, 388 is minus 78. 240 minus 310 at minus 70 is minus 62. Okay, 78, 70. Okay, so here I can see that minus 78 doing plus 8 will give me minus 70, and minus 70 plus 8 will give me minus 62. So the difference between this number and the missing number, whatever that will be, that I can get by adding plus 8 to minus 62. That will give me minus 54. Right? That will give me 124. That is my missing number. There can be another logic for this question. If you're well versed with squares of numbers up till 20 or 30, you're completely memorized, then you'd notice that 388, 310, 240, 178, my missing number. 388 can also be written as 20 square minus 12. 20 square is 400 minus 12 gives 388. 310 is 18 square minus 14. Check it if that is correct or not. What is 18 square? 18 square is 324. 324 minus 14 is 310. 240 is 16 square minus 16. 16 square is 256. 256 minus 16 gives us 240. 178. 178, 14 square. 14 square is 196. 196 minus 18 gives me 178. So the logic is the square of only even numbers, that is reducing. 20, 18, 16, 18. Squares of even numbers, that is reducing, and along with that we are subtracting even number, that is increasing. So the next number should be, here the logic was reducing square of even number and increasing even number in difference. That is my logic. So reducing square, so my new number would be 12 square minus and increasing the difference. Next even number after 18 would be 20. So this gives me 144 minus 20, that is 124. We are getting the same answer from this logic as well. Okay, let's do the next question. Find the wrong number in the given series. Pause the video and try to solve. Okay. So here again you notice that we are starting with a very small number 1 and reaching to a relatively bigger number. I wouldn't call 300 ish number is very large, uh, but it's bigger enough with respect to 1. There is a huge jump, so there must be some multiplication or square or cube involved here, but I cannot, by just seeing the numbers I cannot really understand the pattern right away. So let me just take a difference for starters, consecutive difference. So 7 minus 1 6, 31 minus 7 is 24. Already I am seeing that these are multiples of 6, so that's a good news. Let's continue. 85 minus 31 is 54, again a multiple of 6. Great news. 181 minus 85 is 96, again a multiple of 6. Great news. So it seems that all the co consecutive difference of consecutive numbers are multiples of 6's. Let's see, this 333 minus 181 is 152. 152 is not a multiple of 6. So I have a feeling that this number is my wrong number, but then what will be the correct number? Let's figure out the logic. Hmm. Let's see the multiples. Since all these are multiples of 6, let's write them in the form of multiples of 6. So 6 can be written as 6 into 1. 24 can be written as 6 into 4, 24. 54 can be written as 6 into 9. Yeah, look, 4 is a perfect square, 9 is a perfect square. 96 can be written as 6 into 16, again a perfect square. So it's going 6 multiplied by squares of integers. So this is 6 into 1 square, this is 6 into 2 square, this is 6 into 3 square, this is 6 into 4 square. So this must be 6 into 5 square. 5 square is 25. 25 into 6. 6 into 25. 25 into 6 is 150. The difference should be 150 and not 152. If this is if the difference should be 150 instead of 152, that means this is my wrong number and it should be 331. That is my answer. So here the logic was difference between two consecutive numbers in the given series can be expressed as 6 into square of integers. So that goes without saying that this is not an hard and fast rule. This can be uh, 7, this can be 8, this can be anything. This number basically can be anything that is a constant multiplied by an integer and its squared or cubes. And this integer may keep increasing, can keep decreasing. So this is basically a constant into integer that can increase or decrease its squared or cube. This is my logic. And this is not the actual number, the consecutive difference follows this pattern. Consecutive difference follows that pattern. So at the very starting I told you that there must be, since there is a huge jump in numbers from 1 to 30, 300, 300-ish, so there must be some multiplication square or cube. So you see there was a squared involved, that was squared and multiplication both were involved, but it was not involved directly in the numbers itself but in the consecutive difference of the numbers. This was an important one, remember this. Let's see the next question. Try to do on your own first. Pause. This is a fairly easy one. Okay. So, uh, here I can see that the jump between the numbers are almost not there. So there cannot be any multiplication, cubes or squares involved. But what I am noticing is that from first number to second number it is increasing, but from this second number to third number it is decreasing. That means there is a chance that something alternate addition subtraction is going on over there. So I'll think in terms of that. Here it is increasing, but here it is decreasing. So there is a chance that alternate addition or subtraction can be there. I'm not sure, but this is my first observation from the series, and I will start thinking in those lines. I'll not go and think in the lines of cubes and squares or multiplication. So let's find the difference first. 32 minus 22 gives a difference of 10 plus 10, but 23 minus 32 gives a difference of minus 9. Okay, I don't know this, and whatever this number be, there would be some difference between that number and 23, and there would be a difference between 24 and this missing number, and the difference between 30 and 24 is plus 6. So alternate add or subtraction can be there. So I am seeing the alternate pattern plus minus, and then difference themselves is reducing by 110 to 9. So can it be that this will be again plus 8 and minus 7? Makes sense. 23 plus, let's see if this works. If 23 plus 8 will get a number, and that number minus 7 do it, if that really gives me 24, that means my logic is correct. So 23 plus 8, 23 plus 8 is 31. 31 minus 7 indeed gives me 24. That means my logic is correct. So here my logic was alternate addition or subtraction of reducing number. So this was my observation from just seeing the number before I solved the question. Mm, and this is my final logic. I didn't know, while I observed the question, I did not know that the consecutive difference themselves would be reducing from 10, 9, 8, 7, 6. I could have make a guess that whatever the difference is, they are going in alternate, might be going in alternate addition, subtraction, plus minus. People can also, some people would like, can also remember this logic as hmm, plus of even number and negative of odd number. For and this is again the number, it's the consecutive difference. Consecutive difference. So if my consecutive difference is even, that is plus, and if my consecutive difference is an odd number, that is negative. Some people can think also in terms of like that also. So uh, 10, 8, 6, these are all in positive, and 9, 7, all the odd numbers are in negative. An extension of this logic can be just the opposite of this, or the vice versa of this, that mm, negative even number, that goes without saying, and positive of odd number. That can be another logic. That the vice versa. And alternate another vice versa from this statement can be another vice versa from this statement can be alternate addition or subtraction of increasing number. So the consecutive difference, instead of reducing from 10, 9, 8, 7, 6, it could have increased 10, 11, 12, 13, 14 with alternate addition, subtraction. That is an also logic. This was an important one. Hopefully this was understandable. Let's go to the next question. Find the wrong number in the series. Pause and try yourself first. Okay. Okay. Find the wrong number in the given series. So you see, 1006 is a big number, but with respect to 250, not much of a big number. So there can be, but again, still, up until the first half almost, the jump between the numbers are not very significant. And the later part of the series, the jumps from 430 to 222 was huge, and even large jump is there between 622 and 1006. So this gives me an idea that mm, this gives me an idea that there may be some sort of multiplication involved in the consecutive difference. Multiplication involved in consecutive difference. Whenever I say consecutive difference, that means the difference between the consecutive numbers given in the series. Some kind of multiplication might be involved. Um, Squares and cubes may or may not be involved. Let's see. Let's calculate the consecutive difference first. So 262 minus 250, difference is 12. 26 minus 262 is 24. There we go. 12 into 2 is 24. There is multiplication involved with 2. Let's continue. 333 minus 286 gives us 47. 430 minus 333 gives us 97. 622 minus 43 is 192, and 1006 minus 622 is 384. So I have calculated the consecutive difference. I have to find the wrong number, and till my observation I have narrowed down my logic that it might contain some multiplication in some form. So I can see that 12 into 2 is 24. 12 into 2 is 24, and again I can see that 192 into 2 is 384. 2 into 2 4, 2 into 9 18, 1, 2 into 1 2, yes, 384. That means my consecutive difference is doubling. That means this is for 24 into 2 is 48. My difference is 47. That means this is my wrong number. if, if I do multiply it by 2, and then I will get 48, and 48 times 2 I get 96, and indeed 96 times 2 again I get 192. That means my consecutive difference is getting multiplied by 2, right? So if this difference is not 47, it's 48, that means this is my wrong number. It would be 334. It was 47, now my difference has increased by 1, so 334. And this is my 334, and this is my 96, so 334 plus 96 is 430. So this was my wrong number. So here what logic played out? Consecutive difference getting multiplied by some integer n, or I should say the logic is next consecutive difference is equal to previous consecutive difference multiplied by some integer. So what I mean by this is that, so my next consecutive, if my is 24, this consecutive integer is equal to my previous consecutive difference to this. Previous consecutive difference with respect to 24 was 12. 12 into 2. This is what I mean. And uh, of course, not to say that this integer for this case is 2. This integer can change, or even this integer can be in increasing form or decreasing form. So 12 into 2, 24 into 3, 48, uh, 48 into 4, 96 into 5. So the integer with which it's getting multiplied, it can keep increasing or decreasing as well, needless to say. So that is my logic in this question. Let's do the next question. Pause and try to solve on your own first. Okay, so first thing to note that here in this question a combination of two previous things will come in use. Number one is that going to 6 from 3, there, so there's a plus, but from 6 to 30 you're Yeah, sorry, my bad. No, it isn't completely increasing series. My bad. Okay, but one thing is that it starts with 3 and goes till 192. Not a very big jump, but there might be some sort of small multiplication, if not cubes and squares might be involved. One thing I can straight away see is that mm, 3 into 2 gives me 6, 30 into 2 gives me 60, and with alternating. So here here I'm not 6 into 5 is an option, but again I cannot multiply anything to go to 84. Let's see the difference. The difference is 24. Okay, here the difference is also 24. Okay, so alternately it's getting multiplied by 2 and a difference of 24. That's how the series is going. That means this missing term would be 84 multiplied by 2, that is 168. 168, and let's check if this difference is 24 at all or not. If that is 24, then our logic is correct. 192 minus 24, 12 minus 4, 8, 3, 9 minus 3 gives gives us 6, 168. Yes, so it is 24 indeed. So I said there in the beginning only, by looking at the slide, mm, that jump in the later part, that starting from a small number 3 and in the later part we are reaching to a number which is relatively bigger with respect to 3, but not very big, but relatively somewhat bigger. So there might be some sort of some pokey kind of multiplication, you can say some sort of multiplication is there. Mm, chances are less of chances are less of squares or cubes. Squares or cubes usually come when the numbers are very big. This was straightforward. So the logic was that alternatingly alternatingly mm, multiplied by an integer multiplied by an small integer and addition of an constant term, that is 24. In this case it was 24, in this case it was this small integer with which it is multiplying was 2. So needless to say that they can change. So the integer by which it is getting multiplied can be 3, 4, 5, anything, and the constant term that is being added, it can be 24, 25, anything, any constant term. So that is my logic. And remember, this is not uh, this operation is not on the consecutive difference. This number is itself on now. This operation is on the numbers itself, unlike the previous question where the operation was on the consecutive difference. I hope that was clear. Let's go to the next question. Try solving it. Pause the video. Okay. In this question, we have to find the missing term. What is the first observation? By looking at the numbers, you can see the first observation is that I am starting with a very small number 5, and by the end I'm reaching till 2700 ish. It's a huge jump. We're going crossing thousand to thousands by starting with a single digit number. So the pattern that is being followed, it must involve some sort of mm, multiplication with large number, or a number that keeps increasing, or a number that keeps increasing, or squares or cubes. Even if squares, it will be squares of large number. Let's see how we can let's try to identify the pattern over here. What pattern is it following? In So when the difference is so huge, um, the pattern can be on the consecutive difference on the number themselves as well. So this operation could be on consecutive difference, or mm, on the number themselves. Mm. So whichever one you feel, you can, by seeing one or two numbers is coming close, uh, go for that option first between both the two. Otherwise, no need for unnecessarily calculating the consecutive difference if we don't need it at all. So for example, I can see that mm, the cube closest to 61 is 64. Mm, the cube closest to 213 is 216. The cube closest to 5 is 8. So my cubes, or my perfect cubes, are quite close to the numbers themselves that is given to us. It's to the number themselves that is given to us. So first I'll try with this option. Mm, If my logic holds, then well and good. No need to find the consecutive difference at all. If it doesn't work, then I will find the consecutive difference and see that if my consecutive differences themselves follow any pattern of cubes or squares or not. But in this case, I can see the number themselves are close to the cubes of certain numbers or perfect cubes. So let's see somehow we can get them or not. So mm, we can write 5 as we can 5 write as 8 minus 3, 61 as 64 minus 3, mm, 213 as 216 minus 3, 5, the cube closest to 509, uh, 512, 512, 2 to the power uh, mm, or 8 cube, 8 cube is 512, so 512 minus 3 gives me 509. So my logic seems to be working. Okay, let's write these cubes in the form of their base integers. So if I do that, then I can write this as I can write this as 2 cube minus 3, this as 4 cube minus 3, this is 6 cube minus 3, 512 is 8 cube minus 3. So I am seeing that cubes of even numbers, uh, cubes of increasing even numbers and minus 3. So the next term should be, this term should be 10 cube minus 3, right? 10 cube is 1000 minus 3, that is 997. Yes, that is my answer. We did not need to find the consecutive difference. So in you saw how I narrowed down my logic by seeing that such a big jump in the numbers, from starting from 5 to 2700. I know that uh, there must be some multiplication with large number, there must be some squares of large numbers involved, or cubes might be involved, and these can be involved in the number themselves or in on the consecutive difference of the number, just like in all the previous questions we have been seeing till now. These things can be on the consecutive difference or on the number themselves. So just by observation, just because I know I have memorized the cubes of first 10 numbers, I know that 8 cube is 512, 6 cube is 216, 4 cube is 64, and I can see my these numbers that is given to us are close to my perfect squares that I have memorized. So I just expressed them in the term, in the way, mm, that is given to us, that how I can, if this is my perfect square, 64 is my perfect square, how I can reach till 61 by minus 3, and we did that for the other numbers, and I saw that it is minus 3 for all the cases, so it's following a pattern. And when I express those cubes in forms of 2 cube, 4 cube, 6 cube, 8 cube, then the pattern was completely clear to me that the cubes are of even number. Hence, my logic is cube of even number, cube of even number minus an integer. Needless to say, this integer can keep increasing or decreasing in other questions. In this question, that integer was 3 constant, but in other question the pattern can grow like 2 cube minus 3, 4 cube minus 4, 6 cube minus 5, 8 cube minus 6. So that integer with which we are uh, subtracting, it can be a constant or keep increasing or decreasing. And needless to say, the another version of the same logic would be vice versa of this. Cube of odd number minus integer, that can keep increasing, decreasing, or even constant. In this case it was constant. So this was my logic, this was my observation before starting the question, and this is my logic. Okay, Let's do the next question. Pause the video and try to solve on your own first. Okay. Mm. So in this series, all the numbers are big. So mm, since all the numbers are big, my observation uh, would say that we can go for consecutive difference in this case because I can see all the numbers are big and it isn't continuously decreasing series. All the numbers are keeps getting smaller and smaller as I move forward mm, from left to right. Also, one thing I cannot help but notice in this type of question where all the numbers are big and the difference is not very huge or the huge jump between the numbers is not there in this cases. mm, in this cases consecutive difference can be a solution. Other solution can be that mm, express the numbers themselves in some form of perfect square or cube. So I can see from my observation because I know I have memorized table of squares till 30. I can see that uh, only the last three digits 625 is 25 squared. 576 is square of 24. 529 is a square of 23. 23 square is 529. 22 square is 484. 20 square is 400 and 19 square is 361. So all these ones in the front are just placed in front of perfect square on the thousandth place, just like that, meaningless. So my pattern would be 1 followed by 21 square. So 21 square is 441. I'll just put 1 in the front. That will be my number. This is an unique question. Let's do the next question. In the following series, find the wrong number. So let's take the consecutive difference first. Uh, Consecutive difference is 474 minus 249 gives me 225. 15 square, cool, a perfect square. 699 minus 474 is mm, hmm, 1 second. Okay, 699 minus 474 is again 225. Okay, that is 15 square. But this is breaking my pattern. I thought that all the consecutive difference would be 15 square. That would have made my life easier. But this seems to be not the case. This consecutive difference is 576. But 576 is indeed 24 square, and these are 15 square. 15 square, 15 square, this is 24 square. There's no relation between 15 and 24 whatsoever, apart from both of them being a multiple of 3. I don't know. Let's continue. Again, 1500 and 1275 is 225, 225, again 15 square. So it seems that if this difference is also 15 square, then that means this is my wrong number. Let's see what is the difference for this one. 138. It's not even a perfect square. What's going on? So uh, when you have used your arsenal of consecutive difference or expressing the consecutive difference or the number themselves in forms of mm, squares or cubes, when I've used all this and still do not find anything, then start looking for things like sum of digits, or prime numbers. Start looking for these things then. And sum of digits, prime number, they can be on the number themselves, on the number itself, or on consecutive difference, both, whichever seems closer to your answer, choose that path. Let's see where do this 15 is coming from. If I see uh, sum of digits, let me check. 2 plus 4 plus 9, 9 plus 2 11 is 15. Okay, so sum of digits of 249 is 15, so 15 square. Okay, 474, 7 plus 4 is 11, 11 plus 4 is again 15. Okay, my sum of digits of 474 is again 15, that's why 15 square. Okay, what about 6999? 9 into 9, 9 plus 9, 18, 18 plus 6 is 24. Sum of digits is 24, okay, 24 square. Okay, great. What about 1275? Okay, uh, 7 plus 2 9, 9 plus 1 10, 10 plus 5 15. Okay, again 15. Sum of digits of 1275 is 15, so 15 square. Great, great. So if this is for okay, this is okay, this is okay, this is okay, this following sum of integers of this the square of the sum of integers of 699, this is the sum of square of sum of integers of this number, that means this should be sum of integers of this 5 plus 1 6, should be 6 square. That means the consecutive difference should not be 138, it should be 6 square, that is 36. And this number is my wrong number, it should be 1536. That is my correct number. So here in this question the key learning is that um, when you have applied, found out the consecutive difference and you cannot think, सर पैर कुछ नहीं मिल रहा इसके आगे कर क्या है, करना क्या है, किसी स्क्वायर क्यूब के फॉर्म में आ रहा है consecutive difference, लेकिन फिर भी उनसे कुछ पैटर्न नहीं बन पा रहा है, एब्रप्ट consecutive difference और स्क्वायर्स क्यूब्स के फॉर्म में आ रहे हैं. जैसे यहाँ पे 15 स्क्वायर परफेक्ट स्क्वायर आ रहा था लेकिन एब्रप्ट है. यहाँ पे 3 15 स्क्वायर है, एक 24 स्क्वायर है, 138 किसी का स्क्वायर है ही नहीं. तो देवर consecutive difference squares or cubes, they are seem to be coming but they are abrupt. उसको लेके करना क्या समझ नहीं आ रहा. Then look for these two things, sum of digits or prime numbers. This was a unique question again. This was an unique question, previous one also. Let's see the next question. You have to find the missing number. So in this case, the numbers, the difference between them, let's start with the consecutive difference. So difference is minus 45 minus 15 minus 7.5. ओके, यहाँ से ज़्यादा कुछ मिल नहीं रहा है मुझे. We can also see it in this form that 90 into 1 by 2 is 45. 45 से 30 जाने के लिए I can multiply 45 with multiply 45 with 2 to get 90 and divide by 3 to get 30. So multiply by 45 with 2 by 3 and 30 से 22.5 पे जाने के लिए I can multiply 30 with 3 to get 90 and divide by 4 to get 225. Okay, so the pattern is following in terms of increasing numerator and increasing denominator. So the next would be 22.5 into 4 by 5 and whatever that number would be multiplied by 5 by 6 should give me 15. Let's see if our theory is correct or not. So 22.5, we can write 22.5 as 90 by 4 into 4 by 5. So 4 gets cancelled out. Into 18. So if missing term is my 18, do I get 15 by multiplying 5 by 6? 18 into 5 by 6, 3 into 5, 15. Yes, we are getting 15. That means this logic is my correct. So here the logic is mm, multiplication with fraction uh, with numerator increasing multiplication by fraction where my numerator is increasing and denominator is increasing as well simultaneously by 1. And needless to say, there can be many other variation of this. For example, multiplication of fraction where multiplication with fraction where number A numerator increases, denominator decreases, numerator decreases and denominator increases, the vice opposite of this, or complete opposite of this, where both numerator is decreasing as well as denominator is decreasing. And here the numerator and denominator is increasing, increment by 1. It here the change increase or decrease can be uh, in terms of integer more than 1 as well, needless to say that. So remember the other variation of the same logic as well. This is one a unique one. Let's see the next question. Find the wrong number over here. Okay, here is another this is an important question because this type of series has an important property. Wherever there are two numbers repeating itself, whenever two numbers are repeating itself, that means multiplication with 1 is there. There are no other operation of addition or subtraction that will give me this. Multiplication of 1 is involved, right? Multiplication or division by 1. So 1, it can be in multiplication format, division by 1, multiplication by 1, division by 1, or multiplication by any integer in whose exponent you have 0. Example, 2 to the power 0 is 1, 3 to the power 0 is 1. Basically dot 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 any integer to the power 0 is always 1. So multiplication by integer to the power 0 or division by integer to the power 0. So by all the four formats only, this is the only four ways in which two numbers can repeat themselves in a series, right? So let's see how we are getting 40 from 80 by multiplying half or dividing by 2, then multiplied by 1. So This is half, this is 1, it is increasing by, so multiplication factor has increased by half. Here it should also increase by half again to reach 1.5. Half 1, 1.5, that is 3 by 2 should be the my multiplication factor with 40. So 40 into 3 by 2 gives me 20, 20 into 3 is 60. So this is my wrong number, this should be 60. Let's validate our hypothesis. If the same logic follows, uh, by multiplying from 60, if we can get 120 and 300, so we're increasing half in the multiplication factor. Okay, so after 3 by 2, if I increase half, I'll get multiplication factor as 2, and again I'll get a multiplication factor as 2.5. 2.5. Okay, let's see. Okay, yes, 60 into 2 is 120, so that is indeed correct. Let's see if 120 into 2.5, 120 into 2.5 is 300 or not. So I can write 2.5 as 5 by 2, half of 5 basically. 5 half RI. So 120 by 2 is 60, 6 into 5 is 30, and 0, 300. Yes, we are getting 300, that means our logic is correct. So as soon as you figured out there is a multiplication by 1, because the numbers are repeating, and since multiplication is there, and this is, you can figure out from 80 to reach 40 you have to multiply by half. From there you could have guessed the logic. So here the logic was multiplication with a multiplication factor that keeps increasing multiplication with an that increases by half. So similarly, the another version of this can be the same thing, where it would be decreases by half the number. Just the reverse. If it would have started by 2.5, it would have come 2.5 to 1.5, 1 half, like that, decrease by half. So this is my logic. Let's see the next question. Yes, let's do this question. So I can see from observation that it's starting with a small number 3 and going up till 2000 plus. So it's a very huge jump towards the later part. So 345, 201, it's jumping quite a bit, but in the later part the jumps are huge that it has reached by the end till 2073. So this point I'm repeating again and again. So there must be some multiplication or squares or cubes. There can be some sort of these things involved in either consecutive difference or in number itself. So I'll take the choose first, which will seem appropriate. In this case, I can see that 3 is close to 4, that is 2 square, perfect square. 45 is close to 49, that is 7 square. But again, 201 is close to 216, that is 6 cube. And again, 543 is close to 512, that is 8 cube. So there are squares and cubes both. If they would have been either all near to perfect squares or perfect cubes, uh, then involvement of some sort of multiplication, squares or cubes in the number itself, I would have gone down this route. But since there is a mixture of squares and cubes, this route seems less probable. Let's find the consecutive difference first, then check for how we can how cubes or squares or some sort of multiplication of big number is involved. So to calculate the consecutive difference, the difference between 45 and 3 is 42. 201 minus 45 is 156. 553 minus 201 is 342, and whatever be the number will follow the same pattern that they are following. What is the pattern that they are following? So let's check perfect square near to them. So the perfect square near to 42 is 36. Perfect square close to 156 is 144, and perfect square close to 342 is 324. Okay, so and to get 42 from 36, I have to add 6. 36 plus 6, 42. 144 plus 12 will give me 156, and 342 plus 18 will give me 324 plus 18 will give me 342. So I am seeing a pattern, perfect squares, 36, 144, 324, and addition with multiples of 6, for example. And this perfect squares are also in multiples of 6. For example, 36 is, this is nothing but 6 square plus 6. This is nothing but 144 is 12 square. 12 square plus 12. And 324 is nothing but 18 square plus 18. So these are going in multiples of 6. 6, 12, 18. They are squared plus the number itself. So the next number should be, after 18, multiple of 6 is 24. So 24 square plus 24, that should be the number. One one five two plus 24 gives us 1176. 1176 would be my missing number. So by coming down this road and looking at the numbers, finding the closest squares, we have found the solution, the logic. So here the logic was square of multiples of 6 plus the addition of that multiple of 6 itself. So obviously, uh, this is the logic for this question, but to remember in general form, it can be uh, square of multiples of any integer along with that addition of that integer. Okay, let's look at the next question. How to find the missing term over here. So all the numbers in this question are very large, big numbers, right? Mm, they're going in 7250. Usually in question, the number whose square is in 7000 range would be very big. Mm. So, but cubes are cubes of smaller number, small two-digit numbers can reach up to 7000 range. So this must contain cubes. So must contain cubes in some form. Okay. Let's find the common difference first. No, consecutive difference first. The consecutive difference over here is 3375. Consecutive difference over here is 196. Immediately I can see 196 is 14 square and 3375 is 15 cube. Okay, so we can have an alternating square and cube pattern. Let's see the next one, then we can get confirmed. The consecutive difference between these numbers is 2197 and 2197 is 13 cube. Okay, so 13 cube, 14 square, 15 cube. This should be 12 squared, that is 144, and minus 1482. Yes, 1482 minus 1338 is 144. So it's going alternately. Consecutive difference is alternately square of even number and cube of odd numbers. So the next term must be the consecutive difference for the next term would be 11 cube. So mm, 11 cube is 1 1331. This will be my consecutive difference. That means the first number would be uh, 1338 minus 1331. That means 7. That is my missing number. Hope you understood this question, how the logic is working alternately between uh, cubes and squares. Let's do the next question. I have to find this missing term. Let's do it. Just first, here also you can see the number is starting from 1 and going up till 112. It will further increase. So for the last term it will be more than 112 because it is an increasing series. All the numbers are gradually increasing from one another. So, and with respect to 100 200 range, there might be some again multiplication, or again some multiplication or square or cube. It can be either in the number or in the consecutive difference. So I do not feel by looking at these numbers they are near to our perfect square or cubes. Let's just start with these are small numbers. Let's just start with consecutive difference. Consecutive difference over here is 11. Consecutive difference over here is 31. Consecutive difference over here is 69. Can we look at the consecutive difference of consecutive difference again? Let's see, 31 minus 11 is 20, 69 minus 31 is 38, 20, 38, no relation among them. So difference of difference doesn't really make any sense. Let's see in the terms of 69 is closer to my 64. 69 is my closer to 64, which is a perfect cube, plus 5 will give me 69. 31 is closer to 27. It is again a perfect cube. 27 plus 4 gives me 31, and 11 is close to perfect cube, that is 8 plus 3. That means 8 is 2 cube plus 3. 27 is 3 cube plus 4, and 64 is sorry, not 5. 64 is 4 cube plus 5. Okay, so the pattern is the number in the cube increases by 1, as well as the number in the addition also keeps increases by keep increasing by 1. Okay, so the next term should be after 4 cube, 2 cube, 3 cube, 4 cube, it should be 5 cube plus 3, 4, 5 plus 6. Okay, 5 cube is 125 plus 6. So my whatever be the number over here will be the consecutive difference would be 125 plus 6, that is 131. So if uh, this number x would be 112 plus 131, that gives me 3 plus 1 4 2 243. So my missing number is 243. So here my logic was consecutive difference is cube of integer that keeps increasing by 1 plus the next integer. So if 5 cube, then in addition we have 5 plus 1 6, the next integer after 5. Here 4 was cubed and it was added with the next integer after 4 5. That's what I mean. So this is my logic. Let's do the next question. Find the wrong number in the given number series. So obviously starts with 16 and goes till 4000. There must be some multiplication. There must be some multiplications, cubes or squares, right? So there must be some multiplication or squares or cubes, and it can be in consecutive difference or in number itself. Let's see which route we can take. We can see that this is almost 3 times 4071 is almost 3 times of 1356. And 453 is also again almost 3 times of 150, because 15 into 3 is 45, so 150 into 3 is 450. So okay, so 453 is equal to 150 into 3 plus 3. Fine. mm, into 3 plus 3. This 4071 is 1356 into 3. mm, this will be uh, 4068. This will be 4068 plus 3 will give me 4071. Okay, so makes sense. Okay, so this is also multiplied by 3, then addition of 3. 1356 into 3 plus 3 will give me 4071. Okay, this following a pattern. Hmm. But 50 into 3 will give me 150, and 16 into 3 is 48 plus 2, so into 3 plus 2, so 50 is equal to 16 into 3 plus 2, and 150 is equal to 50 into 3 plus 0. Hmm. Let's see this one. 1356. Okay. Uh, 4 into 400 times 3 is close to 1300. So 450. Sorry, 400 into 3 is 1200. So 450 into 3 should be 1350, close to this only. Okay, makes sense. 453 into 3, mm, into 3 9, 3 into 5, 1359. I have to go to 1356, so I have to subtract 3. 1359 minus 3. So to go from 453 to 1356, we have to multiply by 3 and subtract 3. Okay, so I am seeing that alternately, into 3 minus 3, so this should be into 3 plus 3. So if this is into 3 plus 3, then this number is 51. If this number is 51, then 51 into 3 is 153, minus 3 will give me 150. So into 3 minus 3, yeah, makes sense. So alternately, into 3 plus 3 is going and into 3 minus 3 is going. That's the pattern. So here, mm, the multiplication was involved and in the number itself, not in the consecutive difference. And how did I find out? I found out by just by noticing the numbers that uh, they are multiplying by 3. By multiplying one number with 3, I am reaching quite close to the next number. How did I find out? I found out that multiplication is involved and in the number itself. How did I find out? I found out by the observation that multiplying 3 with the with the given number, with the current number or with the present number, gives me close to the next number in the series. And not just for only one, only for no, not just for only two pair of numbers. For two, three set of pairs, I noticed that by multiplying 3, I'm reaching to the next, getting close to the next number. That's how I chose that route and did find a pattern over there. So the logic over here was multiplied by an integer. In this case it was 3, and alternately added or subtracted that integer. In this case our integer was 3. So a more advanced version of this same logic would be where this integer keeps increasing or decreasing. Integer keeps increasing or decreasing. What I mean by that, in that case it would be into 3 plus 3 into 4 minus 4 into 5 plus 5 into 6 minus 6 into 7 plus 7. So I'm multiplying with an integer that keeps increasing from 3, 4, 5, 6, and alternately alternately adding and subtracting. Once I'm adding and alternately I'm subtracting, plus minus, adding and subtracting that integer that mm, which also keeps increasing or decreasing. Here's an example for a more advanced version of the same logic. Advanced logic for the same. Let's go to the next question. Find the wrong number in the given series. So again, starting with a small number 4 going up till 600 each must be containing some sort of multiplication, square or cube, must be some sort of multiplication, square or cube, and they can be in either consecutive difference or in number itself. I hope by now this concept is clear. Let's see which route to take. I can see that 4 into 3 gives me 12 plus 3 will give me 15. Again 15 into 2 will give me 30 plus 2 will give me 32, and again 32 into 3 will give me 96. plus 4 will give me 100. Okay, this 100 might be the wrong number because it's not matching the pattern. I was expecting alternately it will be multiplied by 3 and adding with 3, and alternately multiplied by 2 plus 2 into 3 plus 3, alternately into 2 plus 2. So if here I would have had a 3, then that would have made sense. 100 might be the wrong answer. If 100 is, let's check this one. Mhm. 200 into 3 gives me 600, plus 3 will give me 603. Yeah, makes perfect sense. This makes perfect sense. This is okay, this is okay. That means 100 is my wrong number, but what it would be. So this would be 3, then my 100 would be 99. If this is 99, let's check if it's coming or not. 99. So here it was multiplied by 3, here multiplied by 3, here multiplied by 3. So and alternately it's getting multiplied by 2, so it will be also get multiplied by 2. So 99 into 2 plus 2 should give me 200. Let's see, 99 into 2 is 198, plus 2 is indeed 200. Okay, so this is my wrong number, it should be 99. And pattern, or the logic is very similar to our previous question, where alternately we're adding and subtracting, where but in this case, uh, into 3 plus 3, into 2 plus 2, into 3 plus 3, into 2 plus 2. So this is alternating itself. That's how it's going. So I can say the logic as multiplied by integer plus the integer itself, and in the next iteration it would be multiplied by another different integer, in this case 2, summation of plus that different integer itself. So this is my logic, and they are alternating among each other. They are alternating among each other. Let's see the next question. Okay, all the numbers are big numbers here. So there might be some uh, squares and cubes involved. Let's just first take the consecutive difference. Difference is minus 4 plus 15. Okay. By this I got the observation that there must be some alternating situation is going on, minus plus, because this is not strictly increasing or strictly decreasing series. Once it is decreasing, again it is increasing. Okay, the next is minus 31 plus 49, again minus 121. So I can clearly see that this is 11 square, this is 7 square, this is 2 square, it cannot be square of odd numbers because here then 9 would have come, but 9 is not there, 9 is missing. If I am, and it cannot be odd number because we have 2 square as well, 2 is even number. But one thing that is common is that 2, 7, 11, they all are primes. They all are primes. So the next prime should be 2 cube, 3 cube, and this should be, sorry, 3 square, this should be 5 square. Okay, let's see if that works. If this is 3 square, then this would be plus 9, not plus 15. This is plus 9. 196 plus 9 gives, will give 705. And if this is 5 square, this should be minus 25, not minus 31. And then 705 minus 25 should come my 680 if my our logic is correct. 55086, yeah, 680 plus 25, that means our logic is correct. So this is very important question in the sense that, or the important logic is that consecutive difference is square of primes, and the primes keep increasing. And needless to say, an alternate version of the same logic would be where the consecutive difference would be square of primes, but the primes will keep reducing slowly from 11 square to 7 square to 5 square, like that. From it will be reverse direction. Here we went from 2 square, 3 square, 5 square, 7, 2, 5, 2, 3. In this case we went from 2, 3, 5, 7, 11. In this case it would be the reverse of that. 11, 7, 5, 3, 2. Hope this question was clear. I just want to show you something that I explained previously. Where is it? Yeah, in this question, mm, yeah, this is what I had said earlier. This is what I had said earlier, that we have taken consecutive difference, they don't make sense, or even if they make sense, if we have squares or cubes in the consecutive difference. Mm, but there is a mixture of squares and cubes. For example, here there was no, in the previous question there was a mixture of both squares and cubes. That's why we discarded this logic and went for a step further and checked the sum of digits. But in this case we had uh, 7 11. It was easy to assume that it is a square of odd numbers only. But then you remember that 9 is missing, 2 is there, uh, 2 is an even number, 9 is missing, so it cannot be uh, anything related to odd number or even numbers. But one thing can be that 7 11 they're prime numbers. So I started thinking in the terms of prime numbers and it matched the pattern. And one thing you notice that in both the series, in this series, the numbers are big but close to each other. And in the previous question also, here also, the numbers were big but close to each other, not very, very far away. Okay, let's do the next question. Find the missing term. The numbers are close to each other. Uh, let's start with finding the consecutive difference. Consecutive difference is 1, 2, 6, 22. Doesn't really make much sense. Let's take the consecutive difference of consecutive difference, double consecutive difference I say. So 1, 6 minus 2 is 4, and 22 minus 6 is 16. Okay, okay. Now it makes sense somewhat, because 1 we can write as 4 to the power 0. Um, 4 we can write as 4 to the power 1, and 16 we can write as uh, 4 square. 4 squared. If this is true, then next difference of difference would be 4 cube, that is 64. If this is difference of difference is 64, that means my difference would be 22 plus 64. 4 plus 2 6, 6 plus 2 8, 86. Then my missing number would be 432 plus 86. 6 plus 2 8, 8 plus 3 11, 4 plus 1 5, 518. 518, that is my correct answer. So this is a very again a very important question from the term, that a very simple looking question uh, can be solved without much calculation uh, of squares, cubes, without mathematics much, by just by double consecutive differentiation. Uh, I'm call this double consecutive difference. So the uh, logic over here is double consecutive difference follows powers of 4, powers of an integer, let's say. In our case the integer was 4, but for any other question it can be 4, 5, anything. So power of an increasing power, increasing power of an integer. I hope you understand what I mean when I say double consecutive. Double consecutive difference. Double consecutive difference means you have a series given to you, series of numbers. You have taken the consecutive difference, then you have taken the consecutive difference again of the consecutive difference. This is your consecutive difference. You have taken the consecutive difference of the consecutive difference. That's what I mean by double consecutive difference. And this is your logic. This is a very important thing. Many a times a lot of questions can be solved using double consecutive difference. So I'll keep this as important. Keep it in mind. Let's do the next question. Let's see if you can do this question. Okay, so let's just do the obvious that I can think of, I can observe, not even think, I can observe is 3 plus 1 is 4, 4 into 3 is 12, 12 plus 5 is 17, 17 into 7 is 119, and 119 plus 9 is 125. I did this because I could observe from here that 4 into 3 is 12, 17 into 7 is 119. I could notice that because I remember the table of 12 and 17. And if I've got 4, 3 and 7, that means this is going somewhere in the direction of either um, odd number or prime number. But then from 3 to 4 I cannot multiply anything, I have to add 1. And from 12 to 17, then I notice that if we plus, I have plus in the first, then I have multiplication second. It can be somewhat in alternating form or an alternating series. So plus 1 into 3, the next one can be plus 5, can be plus, because I anyway cannot uh, mm, make 12 17 by multiplying anything. I can make 12 17 by adding 5. So this is following odd number and alternatingly adding and multiplication. So the logic in this question is alternating addition and multiplication of odd numbers which keep increasing, by this arrow. I mean 1 3 5 7 9, increasing odd numbers. And an alternative to the same logic would be nothing but alternating addition and multiplication of even numbers that can keep increasing, or in the reverse order keep decreasing. So that can be another alternative logic that is similar to this one. What do I mean by this alternating logic? So of even numbers, so um, plus 2 multiplied by 4 plus 6 into 8 uh, plus 10 into 12, so keeps going on like that, and each of the integer are even and keeps on increasing from 2 to 4, 4 to 6, 6 to 8, keep on increasing. If this would have been in the reverse direction, this is what I mean when I have used the up arrow. Up arrow over here means the numbers keep increasing, and the down arrow means the number keep decreasing, means the reverse of this. So plus 12 into 10 plus 8 into 6 plus 4 into 2. That's how alternately addition and multiplication is going on of even numbers, but the numbers are gradually, the even numbers are decreasing from higher number to lower number. That can be an alternate logic. Okay, this brings to the end of our marathon for number series. Hopefully all the concepts that I have taught you, specifically this concept where mm, by observing the numbers, of, by observing the numbers where you see that it can be a sort of it will contain some sort of multiplication, square, cubes, and it can and that multiplication, square, cubes can be in the consecutive difference or in the number itself, and how to judge which route to take. I have explained through many different examples this same broad concept over and over again, and I've given several logics corresponds to each question. I hope you note them down in a copy in a nice manner and revise them every day. Thank you.